So if you turn to the first page of your exponential worksheet, they're up there. You need both of those. We're going to build both a recursive model and an explicit. Yeah, I'll go ahead and review it. Yeah, it's okay. So the recursive model, there are two ways to do it, and I'm going to write the short way up here. So I think yesterday we talked about 4 plus 0.5 times 4. And then that equaled 6, and then 6 plus 0.5 times 6. Whatever, it doesn't matter. Either way, it works. So it's going to be 9 plus 0.5 times 9. Now, you notice in each of these, this number shows up twice. So we can actually factor out that number. So another way to write it is 4 times, if I divide out a 4, what's 4 divided by 4? 1, plus, if I divide out this 4, what's left? 0.5. So I can actually do 4 times 1.5 for year 1. So year 2 can be 6 times 1.5, and then 9 times 1.5, and 13.5 times 1.5. So if you wrote it down the other way, that's perfectly fine. It works. But today you have to understand that 1.5. And if you get the 1.5, exponential equations are a piece of cake. They're really similar to linear equations. It's just the interest works a little bit different. So why does timesing by 1.5 increase a number by 50%? Because of this. This says I have $4. I'm going to keep 100%. What's 100% of 4? 4. So I get to keep $4, and then what am I going to do? I'm going to add an additional 50%. So 1.5 represents 150%. Meaning, we keep everything from last year, and we increase by 50%. So if the number was 1.6, what would that represent? How much would that be increasing? You would have 160, but you're only gaining 60%. Okay, so how is this different from a linear model? Do you prefer this bank account or the other bank account? This one. How come? You're gaining more money. Why is that the case? The first year we gained the same amount. It was $2 in both accounts. In this model, the interest I earn is going to give me more interest next year. So that first year I have $4, and then I get half of that back, which is $2. Now I have 6. Half of 6 is bigger than half of 4. So every year you get more and more and more money faster and faster. So that one's better. So here's the equation. The recursive equation is y sub 0 equals 4. We start with $4. And then if I want to find any year n, how am I going to calculate that year n? I'm going to take last year. Well, if this year is n, what was last year? One number smaller than n. Well, I don't know what n is, so I just write n minus 1. And that's a little bit confusing. If this year is n, last year is n minus 1. What would next year be? Well, if this year is n and I go into the future 1 year, that would be n plus 1. So n minus 1 is last year and n plus 1 is next year. Okay? And then I'm going to times that by 1.5. Okay? That's for the recursive model. In the explicit model, we don't want to use last year. So we do it this way. For year 1, we take 4 and we times it by 1.5. And that gives me my $6. Now I want to take that value and times it by 1.5 again, except I don't want to write 6. If I write 6, then it's recursive because it relies on last year. So this ends up being 4 times 1.5, which is last year's value, and I'm going to times it by 1.5 again. And notice in year 2, you have two 1.5s. Well, I'm getting a little bit lazy. For year 3, I will have 4 times 1.5. How do I do 1.5 times 1.5 times 1.5? Third power. And I believe that answer is, what is it? 13.5. So 13.5 goes here. And then for year 4, 4 times 1.5 to the 4th is 20.25. And then 4 times 1.5 to the 5th is 30.375. Okay? So the explicit equation is y equals 4 times 1.5 to the x. So that's the answer to that. Now for the explicit equation, we can write what is called the general form, the equation that represents everything. In the linear model, our general equation was y equals mx plus b. M represented the increase, and b represented the initial amount. For an exponential equation, we can use the same variables. But the general form, so this question down here is y equals b times m to the x. And that equation represents every possible exponential equation. So the next question, what part of the equation represents the initial amount? That's always b. Or in this case, it's 4. What part of the equation represents the interest? It's m, but m is a little bit funny here. If m is 1.5, my interest is 50%. If my m is 1.8, then my interest is 80%. So if m equals 1.27, what is my rate? 27%. So you have to take your m value and you knock off that first 100%. Because that's not increased, that represents what you had last year. All right, turn the page over. We have a CD player that's worth $25, and the value of the CD player drops by 40% each year. So I'm going to write some stuff off to the side, and then I'm going to figure out a better way to write my recursive. If your recursive is this way, it's okay. So in the first year, I'm going to take 25, and I'm going to subtract 0.4 times 25. Well, I have two 25s in this case. So if I pull out a 25, what's left in the parentheses? If I divide 25 by 25, I get 1 minus, I get rid of this 25.4, and that gives me a calculation of 25 times 0.6. Does 0.6 make any sense in the story? Can anybody make sense of 60%? Why does 60% make sense? Good. So let's say I were to stack up my money. Here it is. And I'm going to lose, let's move that over a little bit. I'm going to lose 40%. So this goes away. What's left? 60%. So this says, of my $25, I'm going to keep 60% and the rest of it disappears. All right? So the next year, is going to be $15 times 0.6. So up here, I draw another line, and this goes away. The year after that will be 9 times 0.6. So in my calculator, 9 times 0.6, and I get 5.4. So year 3 is 5.4. Now I times that by 0.6. So 5.4 times 0.6, and I get 3.24. And then I times that by 0.6. So 3.24 times 0.6, and I get 1.949. What do you notice about these values as I go down the ending balance column? What's happening to the amount of money I'm losing? So let me continue drawing this. Here's 60, there's 40%. Here's 40%. What do you notice about those pieces that I get rid of? They're getting smaller. So I'm losing money, but am I losing money at a faster rate or at a slower rate? I'm slowing down. How long is it going to take me to have no money left? Right, my CD player will never be worth nothing. Well, what happens when it's worth 1 penny? Then it's worth like 60% of a penny. I've never seen one of those. Actually, they used to make hay pennies, half pennies. That was a normal penny, but yeah, it was worth a penny. The hay pennies were worth half a penny, but we haven't used those in a long time. You might have heard of a half pence. They used that in England. They don't have it anymore. Okay, so for the explicit model, we want to do the same thing, except we don't want to use the past value. We want to use exponent. So the first one is going to be 25 times 0.6. Then the second one will be 25 times 0.6 squared. And then 25 times 0.6 to the third. 25 times 0.6 to the fourth. And 25 times 0.6 to the fifth. So down below where it says the equations, the recursive equation is really similar to what we've seen before. Y sub 0 equals 25. That's my beginning value. So to find any value in the future, y sub n, I take last year. How do we represent last year? Y sub n minus 1. So if this year is year n, last year is n minus 1. And I'm going to times that by 0.6. And remember, recursive equations are really good for filling out the chart, but they're terrible for finding a value in the future. If I wanted to find value 100, I need to know 98, 99, 97, all the way back to 0, which is a pain. So for that, we create the explicit equation. The explicit equation is y equals 25 times 0.6 to the x. All right. What I would like you to do now is graph these equations. So on the graph on the back side, I want you to graph all of those values. And to help you out, here are the values for this side. Oh no. Get rid of these. Okay. Oops, sorry. Let's get rid of that. And then somebody, can I take a picture of your phone? It's not great. Well, all you need are these numbers on the right, and you don't actually need all of them. So you only need to go to 30. So here are the numbers from the front side, and then these are the numbers on the back side. Okay, so that way you don't have to keep flipping your paper back and forth. Graph all of those points on your graph. Are we going to draw solid lines in this case or dotted lines? Do the half years exist? Yes, so we need to draw a solid line. So graph the dots. So 0, 4, 1, 6, 2, 9, and then just draw the dots. Well, so the x values, these are y values. And then the x's will be 0, 1, 2, 3, 4, and 5. And then we have two sets of y values. Yeah. Your graph should look something like this. So the first graph starts at 4, and it increases exponentially. And remember, when we did the linear version, the line was straight. In this case, the line is always curving up. It's always getting steeper and steeper because we're gaining more money than we did the previous year. So exponential equations always end up growing faster than linear equations. Okay? For the other one, we start at 25 and we go down. How long is it going to take that graph to hit 0? It'll never hit 0. And if you notice, these graphs sort of look the same. One's just going up and one's just going down. So the first question asks, what part of the graph represents the initial value? Where do we find year 0? At year 0, which is the y-axis. So that number will always be on the y-axis. Okay? Second question, what would the graphs look like on the left side of the y-axis? So if we look at the first graph, what's going to happen over here? It's going to be dropping. Is it ever going to hit 0? No. How do we find out how much money there was back then? Well, we can use our calculators. So 5 times 1.5, what is the x value that represents last year? Negative 1. So I plug in negative 1. Huh. Well, if you type it in right, it works. So 5 times 1.5 raised to the negative 1. So last year there were $3.33. Well, if I want to go back 2 years, 5 times 1.5 to the negative 2. And if you're lazy like me, you don't have to type it in every time. You can push second, enter, and you can go up here to the exponent and just change the number to 3. Would this same thing work to find some value really far into the future? You say, I want to know how much money there will be in 10 years. So I just go in and change that exponent to 10, or let's say 16. In 16 years, I'd have $3,284, which is really nice because I only spent $5 to begin with. So that's an incredible amount of money. What's that? Yes. Okay. So what happens on the left side of the other graph? What happens over here? It's going to go up really fast. So if I use the other equation, which was 25 times 0.6, if I raise that to the negative 1, that will tell me how much money the CD player was worth last year. $41.66. Okay? And then I can use that to find years in the future. So if I wanted to know what's my CD player going to be worth in 25 years, I just plug in 25. What does that mean? What does 4.1 e to the negative 5 mean? No, it's not negative. 7.1 e to the negative 5 means move the decimal to in the negative direction 5 places. So I take this decimal and I move it 1, 2, 3, 4, 5. Yeah, yeah, it's a really small number. So it's not worth much at all. Probably not. I don't know. Maybe I'd buy it for a penny if I could go shoot it. Okay, so the last question. How can you tell if a bank account is gaining or losing money by looking at the equation, not the graph? The graph is easy. It's either going up or it's going down. How do we tell if an equation is going to go up or down? No, not negative and positive. Let me write two equations. Y equals 6 times 1.1 to the x, and y equals 6 times 0.95 to the x. Right, so this one is going up. How fast is it going up? 10%. 0.1 is 10%. This one is going down. How fast is it going down? So what is 0.95 minus 1 is negative 0.05. It's losing 5%. So if you want to know if an exponential equation is going up or down, there are no negatives in this case. They're all positive. So if it's above 1, it's going up. If it's below 1, then it's going to go down. Right? I can tell you your test scores. I'm not going to hand back the test yet because there's still some people finishing them. But hand in this assignment.